Okay, so now we're going to talk a little bit about the irrational root theorem and the imaginary root theorem. So you already learned about rational root theorem, which was finding the root for a polynomial so that you could then use that root to finish factoring the resulting trinomial and then figure out what all the rest of the irrational and imaginary roots are for a particular polynomial. So we've talked about rational roots. That's what the last entire section was about. This is the other two root theorems in the section. So we did rational root theorem. Now we're doing irrational and imaginary root theorems. Really what these two boil down to is that when you are dealing with finding roots, okay, you have those regular roots, remember, that were whole numbers, 1/2, -2, whatever, but you also have roots that deal with radicals and also deal with imaginary numbers. So what you have to know about them is that they have conjugates. So remember, when you take the square root of something, we always have you do plus or minus square root of whatever it is, 5. So there are two roots, the positive and the negative, okay? So the irrational root theorem is saying to you that if I tell you you have a plus the square root of b, right, as a root, then you automatically know that you also have a minus the square root of b, because you need plus or minus the square root of b. You need both of those situations. And the same thing occurs for the imaginary root theorem. So if I tell you you have a plus bi, then you immediately know that you have a minus bi, because when you take the square root of something that's negative, then you get plus or minus I square roots of 2. So again, when you're dealing with i's, there are 2. Okay, that doesn't happen when you do the square roots. I mean, when you have whole numbers like the root -3, you don't just assume you have +3. You don't do that with rational roots. You only do it with the irrational roots, so those with roots in them, the square roots and third roots and all of that stuff, or the roots that are imaginary that have i's in them. So again, these things are called conjugates. We've talked about conjugates before. Conjugates, remember, are things that are the same exact terms, so they both have the same exact terms. One is positive, one is negative. Same thing here with your radicals, same exact terms, but one is positive and one is negative. So what does that mean for you when solving these polynomials? It means that if I tell you you have the square root of -11, you also need to know that you need to include the square root of +11 in your collection of roots. Okay? We don't always tell you them all. You have to assume them, and you have to figure them out. So if I said, hey guys, you have 1 plus the square root of 3, then you would need to say, oh yes, and we also have 1 minus the square root of 3, because we need its conjugate. Okay? In the second example, if you have 2 minus the square root of 7, you also know that you have 2 plus the square root of 7. If you have the positive square root of 5, then you also have the negative square root of 5. So these 4 roots would be what you would include if I asked you what the roots were of that particular polynomial function. And in this one, you would use all 4. Okay? Now, in the imaginary root theorem, in these examples, we're trying to trick you a little bit because we've included a couple of rational roots. This one is rational, and this one is rational. Those are whole numbers, regardless of whether they're positive or negative. They do not have conjugates. Okay? They're not radicals, and they're also not i's. So in this particular case, it says, given the following roots, find the additional roots. You would not put down -3, and you would not put down +6. Those do not have conjugates. Please make sure that you note that conjugates are just for irrational. So remember that those are radicals, and they are for imaginary only. And so those are i's. That's really important. Conjugates do not apply to rational roots. So the only additional root I need for number 1 is 1 minus I, and the only additional root I need for number 2 is 2 plus I. Okay? Take a moment if you need to, pause the video, write down some notes to yourself about that so that's very clear. We do not want you getting confused. The rational roots do not get included as having conjugates. Okay? So while you do that, I'm going to scroll the page up a little bit and try to make some room. We are going to find all the additional roots, which is what we just did with those 4 examples. We just tacked on the conjugates that were not previously told to us. We're going to write those in their factored form, and then we're going to multiply them out and simplify them in order to get the original polynomial equation. So in the last few lessons, we've been giving you those polynomial equations. We've been asking you to factor them, solve them, give us the roots. Now we're going to say, here are the roots. You tell me the polynomial equation. So we're sort of doing this backward, okay? So I want you to think about that as we're working on it. We're going to be working backward with these things. So let me scroll the page up and get as much room as possible. And that's probably going to be about it. So I'm going to have to erase a couple things sometimes and write over them. So be patient with me here. Okay. So I'm going to give you some roots. 3rd degree, big hint that my answer should have a lead coefficient of a cube root if it's a 3rd degree polynomial. And it has the roots -1 and 2 minus I. This one does not have a conjugate. This one does. So I need 2 plus I. So these are going to be the 3 roots that I'm going to use. So I've added in the additional roots. Now I'm going to write them in their factored form. And so that always is, and when you do this, be very careful. It's x minus whatever, and x minus whatever. And you keep going until you've got all your roots written in their factored form. It is so very important to watch your signs here, knowing that this could be a negative value that you plug in, and it's x minus that value. Okay? So looking at our examples, we have x minus -1. And I always put what I'm plugging in parentheses. That way I'm very careful not to mess up my signs. Then I have x minus 2 minus I. And then I have x minus 2 plus I equals 0. So I'm going to try to multiply this all out and simplify it and get it back to its original form. So I'm going to first change the negative to a positive. So I'm going to have x plus 1. And you might want to write smaller and closer together. We have a couple more steps here. I'm going to run out of space because my marker is really big, so I'm probably going to go into the space below the next example, and then I'll erase it when we start the next example. Okay, it's really difficult to fit all that writing into these little markers, into these little spaces with these giant markers. Here I'm distributing a negative. So when you distribute a -1, all it does is change the signs. So now this is going to say x minus 2, and then negative is going to be plus I. And then in that last parenthesis, again, I'm distributing a negative. So it's going to be x minus 2, and then minus I equals 0. All right, we have a bit of a challenge, and that is that we need to multiply these two sections together. I'm just going to let that x plus 1 sort of hang out here in the front. And we'll worry about it after. You're going to understand why in a second. So now I'm going to distribute. If I have 3 items in my first set of parentheses, I need to distribute every single one of them to the second set of parentheses. So when I distribute the x, I'm going to multiply it by all 3 things in the second parenthesis. That's going to give me 3 terms. When I multiply the -2 times everything in the second parenthesis, that's going to give me 3 more terms. And then when I multiply the I times everything in the second set of parentheses, that's going to give me 3 more terms. I should have 9 terms when I'm done. I'm going to do them each section in a color for you, so hopefully that will be helpful. So I'm going to distribute here, and that gives me x squared. And then I'm going to distribute here. X times -2 is -2x, and x times -I gives me -ix. We like to put the I first. Now let's do distributing the -2 in blue. So -2 times x is -2x. -2 times -2, positive 4. Oh God, ice just fell off the building, scared me half to death. -2 times -I is positive 2I. Okay, so there's my first 3 terms in red, my second 3 terms in blue, and my third 3 terms in green. Ready? I times x. Again, put that I first. We like the I first. So ix. I times -2. So -2I. And then I times -I squared. Awesome. There are my 9 terms. I've distributed everything. Each term I distributed for you in a different color. I love to draw those arrows because it really helps me to make sure I didn't forget something. Some students like to put their finger on the paper and kind of trace it with their finger as they're multiplying. Whatever strategy you need to make sure you don't forget something. Also, knowing that you should have 9 terms when you're done, and then looking at what you have left might help you to not forget one of the distributing pieces. Okay, now we're going to combine our like terms. You'll notice positive 2i, negative 2i cancels. Negative ix and positive ix cancels. And then don't forget that when you have an I squared, okay, negative I squared, this is a negative 1 in itself. And when you multiply that times this negative in front, a negative times a negative makes that whole thing become a positive 1. So this got replaced with a negative 1. So subtract a negative 1 makes that now a positive 1. So when you look at what's left here, there are no more I terms left. Interestingly enough, when we give you a polynomial, we will not give you polynomials with i's in them. If you've noticed, all the polynomial equations we've given you have only had x terms in them and constants. They haven't had square roots in them. They haven't had i's in them. So note to self, when you're working on these equations, all of your I terms and all of your roots should cancel out so that you end up with just a beautiful polynomial when you're done. So if something's not canceling, you've probably made a sign error. You want to go back to the beginning and double check your multiplication, double check your signs, okay? So that's a great hint, something for you to maybe note that should happen every time. All right, let's simplify. So we have x squared, then I have negative 2x and negative 2x. That gives me negative 4x. And then I have positive 4 and positive 1. That gives me a positive 5. And then all I have to do now is distribute my x plus 1. Again, I'll do that in 2 different colors for you. So that is, and I'm writing down here because I'm running out of space, x to the third minus 4x squared plus 5x. Okay, now let's distribute the 1. When you distribute 1, it doesn't change anything. So 1 times x squared is x squared. 1 times negative 4x is negative 4x, and 1 times 5 is 5. All right, let's combine our terms. X to the third, negative 4x squared, and a positive x squared is negative 3x squared. Positive 5 minus 4 is positive 1x, and then my constant plus 5 equals 0. So my polynomial is x to the third minus 3x squared plus x plus 5. It should be a third degree polynomial, and it is. So that would be the answer to the first example that I ran out of space for. Okay, let's try the last example. Again, I'm probably going to run out of space, so let me clear. And I'm going to ask you to sort of ignore this stuff while you're looking at this. And I'm going to write up here and then finish my way. You guys, if you write small with pencil, can probably fill that in right there. All right, so my roots, I, so I also need negative I, and then 2i, so I also need negative 2i. So those are my 4 roots. I have my conjugates all accounted for. If it's a 4th degree, then it's going to be an x to the 4th, and I should have 4 roots. And I do. I have negative I, negative 2i, positive 2i. So I'm good to go. So x minus I, x minus negative I, x minus 2i, and x minus negative 2i. All right, so I've written my roots in factored form. Now I'm going to just kind of simplify those double negatives. So I have x minus I and x plus I. And then I have x minus 2i and x plus 2i equals 0. All right, here's what I'd like you to pay attention to. Let's FOIL out these 2, and let's also FOIL out these 2. Okay, now remember, this is multiplication. So when we're finished with this stuff, we're multiplying all this stuff together. Okay, so we have to be really careful about this. All right, so let's do this. Let me put this in color for you. Again, we're FOILing. So we're going to do x times x and get x squared. And then x times I gives me ix, negative ix, and negative I squared. Okay? So you can see right now that the I square, these ix's will cancel, and that this is a negative 1 times a negative 1. So this becomes x squared plus 1. That's what that boils down to. Okay? Let's do the second set. X times x is x squared. X times 2i is 2ix. And this is negative 2ix. And then this is negative 4i squared. Okay, again, 2ix and negative 2ix is going to cancel. This again is negative 1. Negative 1 times negative 4 makes us a positive 4, which means I have in this parenthesis x squared plus 4 equals 0. All right? So now I'm down to 2 binomials. I'm just going to rewrite down here where I have room. I have 2 binomials that I now need to multiply out. So x times x is x to the 4th. X squared times 4 is 4x squared. That was the first term. X squared times both. Now I'm going to do 1 times both. So plus x squared and plus 4. That was FOILing. First, outside, inside, last. 2 binomials. First, outside, inside, last. Just need to do some combining of like terms. X to the 4th plus 5x squared plus 4 equals 0. There is your 4th degree polynomial. Again, notice all of the I stuff canceled out and you are left with just a polynomial. Okay, nicely done.